C1 Quadratics Example 27. So we need to sketch this graph. It's a quadratic graph. So we know from looking at the equation of the graph that it's got a y-intercept at 7. Let's just label our axes first. We know it's a negative parabola. If we sketch the graph, a negative parabola. We know the y-intercept is 7. So we'd find that by setting x equal to 0. So it crosses the y-axis at 7. We can work out where the graph crosses the x-axis by setting y equal to 0 and factorising. Negative, so we've got minus x and x. 7 and 1. We need plus 7, so they've both got to be negative. When we multiply minus 1 and minus 7, we'll get the 7. So we've got minus x squared minus x plus 7x would give us our 6x plus 7. So our roots are at minus x minus 1 equals 0. If we move the x over onto the right hand side, we've got a root at minus 1. And at x minus 7 equals 0, so we've got another root at 7. So we know the graph crosses the x-axis at 7 and minus 1. The other thing we can work out is the vertex, or the turning point of the graph. Well, you might be able to work out the x-coordinate by symmetry of the graph. And then we could sub that in to work out the y-coordinate. Another method which you'll have been looking at earlier in the booklet is completing the square. Now by completing the square, when we get it into the correct form, we can tell the vertex of the graph. Now the difficulty is, because we've got a negative parabola, we need to take out minus 1 as a factor, and then we can complete the square. So if we take out minus 1 as a factor, we've got x squared minus 6x minus 7. So let's just ignore this minus 1 for now, because if we forget about that, then we can easily complete the square for x squared minus 6x minus 7. So remember, we halve the coefficient of x, so half of 6 is 3. Subtract 3 squared, so subtract 9, subtract 7. So we've got x minus 3 all squared minus 16. Now we need to remember that actually it wasn't x squared minus 6x minus 7. We had a factor of minus 1 in front. We just factorised and took out the minus 1 just to make it much easier to deal with. So if we put a big square bracket around all of that, we've got a negative in front, or minus 1 in front. So if we multiply through by minus 1, we've got minus x minus 3 all squared, and then minus 1 times by minus 16, it'll become plus 16. So we've got our equation in the form where we've completed the square, so we can tell our vertex by these values here. So we know the vertex is at, it's the opposite sign to what's in here, so instead of minus 3 it would be 3, and the y value would be 16. So the vertex of the graph is at 316. So if we just lastly label that on the graph up here, 316, we can tell by the symmetry Distance between 3 and 7 is 4 here. The distance between 3 and -1 is 4. So the graph is symmetrical. We've labelled all the points where the graph crosses the axes and also the turning point of the graph.